Alrighty. So you already started talking about interest that's compounded continuously. Today we're going to talk about interest that's compounded at different intervals and as well as interest compounded continuously like you talked about on Friday. So you already know the formula for continuously compounded. Let's talk about our general compound interest formula. Okay. That is going to be A equals P times 1 plus R over N. It's the NT power. P times 1 plus R over N, all raised to the NT power. Okay, that's the general compound interest formula when it's compounded at different times. Okay, your continuously compounded formula was the one you talked about on Friday, P times E to the RT. Okay, and you use that when you are explicitly told that your interest is compounded continuously. Okay, if you are not told that your interest is compounded continuously, you're going to use the first equation. The variables are the same for both of them. A is your final amount or your total amount after a certain amount of time. P is your principal. What does that mean? Yeah, your starting amount or your initial amount. R is your interest rate. And it always needs to be a decimal. T is your time, and what does that have to be given in? Years. The only other additional variable over here is N, and N stands for the number of times the interest is compounded each year. So if you're told your interest is compounded weekly, N would be 52. If you're told your interest is compounded monthly, your N would be 12. If you're told your interest is compounded 3 times a year, your N is 3. Okay? So you've got to read your problem for that. Please?
So is this used for like bank accounts and stuff like that?
Yeah, like thinking how much interest you gain in a bank account.
Okay, and how did they find E?
E is a number that comes from nature.
Okay.
When you look at like growth of populations and stuff like that, the ratio ends up coming out to be based off this value E.
So it's just like natural magnificence.
Okay. All right. While in 6th grade, Heather invests $20 in a bank account that paid 6% annual interest. She forgot about the account until she found her bank book 50 years later. How much was in the account at that time? Do you see anything in here that talks about compounded continuously? No. So that tells you are going to use your first formula. You must be explicitly told that the account is compounded continuously in order to use P times E to the RT. Okay? On a problem like this, what I like to do is work my way through the problem and label my information. If you choose to write it out like under the formula, like A equals P equals R equals, that's fine. I normally just write on the problem I'm given. So whatever works for you. So that $20, what does that represent? P. 6% annual interest. What's R going to be? 0.06. She found her account 50 years later. So my time is 50. How much was in the account? That means we're looking for A. Okay. So in this case, N is going to be 1. You haven't been told any other different number of times per year it's compounded, so it's going to just be compounded annually. It's going to be compounded 1 time per year. So we're going to let n be 1. Again, n you would have to be told is something explicitly different in order for it not to be 1. All right, so let's go ahead and plug this in. We've got a equals 20 times 1 plus 0.06 over 1 to the 1 times 50 power. Personally, I like to simplify this a little bit before I go to my calculator. So I'm going to rewrite this as 20 times, what is 1 plus 0.06 over 1? 1.06 to the 50th power. Okay, so that's what I'm going to type in my calculator. Every single person needs to be doing this. This is every man for himself. You've got to be the one personally typing this in your calculator so that you know throughout this whole day when you're not getting something. Type this in and then compare with someone sitting next to you.
When we're trying to find money, we don't round, right?
Well, how would we round money?
No, I mean,
Yeah, dollars and cents.
I meant simple for the.
Oh, you can use that, that's fine. Make sure you have units on your answer. You either need a dollar sign or the word dollars.
I mean, actually,
No, that's all right. Yeah, she answers in our first. Yeah, I got
how does this even look like?
All right, you should have gotten $368.40. Please make sure you either have a dollar sign or you've got the word dollars. You've got to have units on every single one of these problems. All right, look at the next one. Take a sec, read through it. Do you see anything about being compounded continuously? No. So choose your correct formula. And every time, guys, I really want you to be writing down this formula. It helps you keep your work organized as well as helps you memorize these formulas. All right, so let's work our way through our problem. Estimate the time. What is that telling us to do?
We need to know the numbers.
Yeah, we're finding T. For an investment of $2,500, so what's that? P. To double in value, A is 5,000, double my principal, 8% interest, R is 0.08, and what's N? All right, go ahead and plug into your information, please. All right, so what I would do is go ahead and simplify this a little bit. Could I divide both sides by 25? What would that give me? So 2 equals, sorry, 2,500. 1 plus 0.08 over 1, that's 1.08. So the T power. Now we're solving for an exponent. We can't get the same base, so we have to use logs. So how do I rewrite this as a log?
Log is
Nope.
log is
1.08 of 2 equals t. Guys, you should be able to turn that into a log without even having to pause. You've got to be super, super confident in your ability to go back and forth between exponential functions and log functions. Yeah, Lindsay?
Why is a log not a natural number?
Because I'm not using a base of e here. I'm rewriting this as a log. Okay? So this I would rewrite as log of 2 over log of 1.08. And if you go ahead and evaluate that in your calculator, everyone should be putting that in their calculator. What do you get?
9 years.
So you're going to get 9.006. It tells us to estimate, so it's okay to go ahead and say 9 years. Questions on that? Okay, on number 3, I want you to read your problem, select the correct formula, identify your variables, and plug in. We'll solve it together, but I want you to get it all set up on your own. Okay, check up here. Hopefully everyone was able to get to this spot. Everyone okay here? Okay, I would simplify this. I would divide by 1,000. So that's going to give me 2 equals, what is 0.12 over 12? So this is going to be 1.01 to the 12t power. What do I do when I have a variable in the exponent that I need to solve for? Okay, so if I convert this into a log, this is going to be log what? Base 1.01 of what? 2 equals 12t. So this is log of 2 over log of 1.01 equals 12t. Then what are you going to have to do? Divide by 12. Type that in your calculator and find your value for t. We're going to talk about the best way to give that answer in just a second, but go ahead and evaluate this equation.
You want it in months?
We're going to talk about how to give the answer in just a second, so go ahead and just get the value for this equation.
The t value you put in has to be in there so you can give your answer your points. You can't say t comes out, you can just say the time. Because of this compound is not close, you would be more accurate if you were to say, oh,
Okay, so when you type this in your calculator, you get 5.805. What? Years. Okay? So what that means is kind of hard to decipher. You walked into a bank and they started talking to you about 5.805 years. That doesn't really connect with us. It's not very practical. Okay? So instead, this bank account is compounded monthly. So what we're really interested in, how many months do we have to leave our amount in our account? So what could we multiply this by? 12. And what do you get? 69.66, which means how many months must you leave your money in this account to reach that $2,000? 70, because 69 wouldn't be quite enough. So the most appropriate answer here is 70 months. Okay? We will try. Excuse me. It's my goal to make sure we tell you how to leave the answer. Let's say how many months, or in years and months, how long. Okay? But just try and be practical with the problem. This problem was talking about months, so we can convert our answer to months. Like,
if it was 69.2 months, would you still round it up?
well, it says, how long will it take the investment to reach? Will it have reached it in 69 months?
Okay, so you're always going to round it up to the next one.
It depends on the problem. For this specific problem, we're asked how long will it take the investment to reach this value. So you can't go down because then you haven't reached that value yet. Okay? All right. Please work number 4. Let's go, guys. Please stay focused.
Continuous.
What's a key word in this problem?
Continuously.
Continuously. So that tells you you're using P times e to the RT. So this is 7750 times e to the 0.04 times 5 power. And you should have gotten $9,465.87. Questions on this problem? Okay? All right, let's look at number 5. You invest in an account. You invested $1,000 in an account, paying an annual percentage rate, compounded daily, based on a bank year of 365 days, and you wanted to have $2,500 in your account at the end of your investment time. What interest rate would you need if the investment time was 10 years?
Like 365.
I don't know. So just go with it. That's the information that the problem gave you, so you're going with 360 days. Okay? Which formula do we use? Compound interest or compounded continuously?
Compound.
Just your compound interest. So don't say anything about continuously. Make sure you're writing out this formula each time. It will help you memorize it, I promise. Label your information. Go ahead and start plugging in. Everyone okay getting to this point?
Yeah.
Are there any questions on that? Okay, I'm going to simplify this at least a little bit. Divide by 1,000. It's going to give me 2.5 is equal to 1 plus r over 360 to the 3600 power. I'm okay with that? What could I raise both sides of this equation to get rid of this 3600 power? Yeah, 1 over 3600.
So it's the 3600 root of 2.5.
I'm sorry?
Does that mean it's the 3600 root of 2.5?
Mm-hmm. So this is 2.5 to the 1 over 3600 is equal to 1 plus r over 360. Okay, if you're going to start typing into your calculator before the end, it's really important that you do not round unnecessarily. Okay? Your calculator stores the previous number. Okay, you can always just use where it says answer to help you guys out. So go ahead and type in 2.5 to the 1 over 3600th power. Make sure you put 1 over 3600 in parentheses.
That's like close to
Okay? Now when you look at that decimal, okay, it's really close to 1, which is why you don't want to round. Rounding will really ruin this problem. Okay? What would be the next step here? Subtract 1. So you can do that without ever retyping your number. Just go ahead and hit -1 and then enter. And that says ANS -1, which means it's going to use the previous answer. Is everyone okay on that?
Yep.
Okay, and then what are you going to do?
multiply by 360.
Yeah, then you're going to times by 360. Again, just type in times 360 and your calculator uses the previous value. That stored value. And what do you get for R? 0.0916, which is what as a percent? 9.16%.
How would you know when to round for that?
Hundreds or thousands are always what you want to err on. Okay, but you're rounding the percent to that, not the decimal version. If you just round that to 0.09, you're into 9%, you're rounding too much. Okay? Now, let's say you didn't use the stored value and you actually just typed in 1.000255 or whatever it was. As long as you have it written down on your paper, that rounded value that you used, so that I can go back in, and as long as you rounded correctly, you'll be okay. But I really, really, really want to encourage you to not round until the very end of the problem. That's your most surefire way to stay accurate, and that's what you're going to need to do in calculus. Okay? You've got to use the stored values and not round intermittently until you get to the very, very end. Does everyone understand that? Okay. Let's look at number 6. And even if you've started number 6, I want you to kind of pause what you're doing and pay attention to the method that I'm going to show you. Because my hunch says it's going to be much easier than whatever method you have started trying. Okay? All right. I have $10,000 to invest. The current interest rate is 3.5% compounded daily. I want to leave the money in the account until it grows to be somewhere between $20,000 and $30,000. How long must the money be left in the bank account to grow to this range of amounts? Okay. Is this a continuous compounded problem? No. So write out your other formula. Okay, and go ahead and label your information in your problem. We are looking for time, and we want it to be between two different A values. So yes, you could work two separate algebraic problems, but I think that that's harder than it needs to be, okay? Instead, we can use our calculator to really help us out, okay? So we've got, I'm going to go ahead and fill in this P part. This is going to be 10,000 times 1 plus 0.035 over 360 to the 360t power. Everyone okay with that? Yep. Okay. We want that to fall somewhere between $20,000 and $30,000. Would you agree with that? Okay. Let's let $20,000 be Y1, this middle portion be Y2, and this third portion be Y3. What are Y1 and Y3 going to look like? Horizontal lines. Delete it and try again. You want the practice, I promise. Okay, what is that middle portion, Y2, going to look like? What type of function is that? It's exponential. What is, map that shape in the air with your finger. What does an exponential graph look like? Okay, it's going to go up. So we have something that looks like that, right? So which section of this graph are we interested in?
The middle section.
Yeah, from one intersection to the next. We're interested in this section, right? So we're going to find this intersection point and that intersection point, and our time has to be between those two times. Okay? So I want everyone to start typing this in. You're going to need some extra sets of parentheses. So go ahead and get that typed in, and then I'm going to help you set up your window. Need to go through one. Careful with the number of zeros. My first time I entered 10,000 is 1,000, and it took me a really long time to find my answer. When you raise that power to 360x, the 360x has to be in parentheses. Okay. So, if you're still having a problem, I'll come check in with you in a minute, but let's talk about this window for a sec. I always start with a zoom 6, -10 to +10 on both axes. All right, we already know that our y-axis has to go up till at least what? Yeah, we've got to be able to see 30,000. So what should we try our y max at? 35,000, 40,000. I think either of those are fine. Okay, I'm going to leave everything else the same and just see where I'm at. Okay, you always got to start somewhere. Don't try and play the whole guessing game all the time. Guess what you know, make an adjustment, and then let your calculator help you. All right, so there's y1. Here comes y2, my exponential curve. Okay, and there's y3. If your graph doesn't look like this, I'll come check in with you in just a minute. Okay, what do we need to increase? The x max, but not too crazy much, right? Because we're getting close. What do you want to try? 100. I think we could try that. All right, we crossed the first one. That's good. And now we've crossed the second one. Okay? All right, here's what we do from here. We need to find these two intersection points, right? If your graph isn't working right now, just hold tight and pay attention to what I'm telling you, okay? And then I will come back and help you with your graph. But I want you to pay attention to this part. So let's find this first intersection point. What am I going to do? Second calc 5. Okay, you guys need to pay close attention to this top line up here. Does everyone see where I'm pointing to? That's the line that tells you which curve you're on. Are you on y1, y2, y3? So right here, we're looking for the intersection of y1 and y2. So I'm going to press enter for y1. Then I see it says y2, so I'm good. And I'm going to let that calculate for me. So at your first intersection point that I had you draw on your paper, I want you to write down 19.805. That's the first time. And what is that time in? Years. Okay, to find the second intersection point, we're going to do second calc 5. But this time we want the intersection of y2 and y3, right? So I'm going to use, this might be something you write down, I'm going to use the up and down arrows to go between my functions. Not right and left. That won't help you. So if I press an arrow up, that puts me up at y3, which is good. So I'm going to press enter. Then it sends me back to y2, but I don't want y2. So I'm going to use up, takes me to y3. I already have that. And then I'm going to take me to y2. Okay, and I'm going to press enter because those are the two I want. And then here's my next x value, 31.390. So those are the two values of years that my account must stay active between those two values of years, okay? You might want to switch it into months or you might want to switch it into days, okay? Either is fine. Just go ahead and try and figure out a best way to put that. Here's what's important. You have to have units. If you leave it in years, that's okay. It just has to say years, okay? General question?
Can we put it in days when we get 365 or 360?
I think I did 365 because even though it's a different bank day, let me see, I did 19. Yeah, I would probably do 365. Just, that's the reason on these things, it's just super important that you write down what you're doing. If you write down 360 or 65, I would give you credit for either of those. Okay? Any other general questions? Okay, I would not put this one in months because it doesn't say anything about months in the problem. Your option would either be in days or years. Okay?